So we're ready to do our first example of a first order linear differential equation. So what I want to do is I want to find the general solution to the differential equation y prime plus 1 over x squared y equals 5 times e to the 1 over x. Okay, this is not an initial value problem, just a general differential equation. And so remember here that the trick is when you have an equation of this form, when you have y prime plus p of x y equals q of x, what you're going to do is you're going to take this p of x function, integrate it, exponentiate it, and that is our integrating factor, which we had called mu. And then we'll multiply both sides by mu and see what happens. So that's our goal. So our integrating factor mu is going to be, let's see, e to the integral of 1 over x squared. The integral of 1 over x squared is negative 1 over x. We don't need a plus c here. I'll let you figure out exactly why we don't need a plus c, but we do not need the plus c in the integrating factor ever. It cancels out, but I'll let you fill in the details of how it cancels out. So mu of x is e to the negative 1 over x. So what we're going to do is we're going to take our differential equation. We're going to multiply both sides by our integrating factor, e to the negative 1 over x. And that means that our differential equation is going to become e to the negative 1 over x times y prime plus 1 over x squared e to the negative 1 over x times y equals, let's see, if I take e to the negative 1 over x and multiply the right side of our equation by that, those exponential terms just cancel and we get 5. Now, the advantage of writing it like this is that notice that the left-hand side is now the derivative of a product, and it's the derivative of the product of y times e to the negative 1 over x. Okay, so when you do this correctly, when you have the integrating factor, you get this function, whatever that is, times y prime, and then the derivative that the product that you're differentiating is this function times just y. Okay, so that's how it works out in general. Because of course, if you were to verify this by actually going through and differentiating this product, you would get the derivative of the first times the second plus the derivative of the second times the first. Okay, so that's how that shakes out. So this tells us that the derivative of y times e to the negative 1 over x will be 5. And then at this point, we can differentiate both sides. Anti-differentiate both sides, and we'll end up with y e to the negative 1 over x is going to be equal to the integral of 5 dx. And when we integrate that, of course, that's 5x plus c. Here we do need a plus c. And then finally, our goal is to solve for y. So what we'll do next is multiply both sides by e to the 1 over x. So this tells us that y is going to be 5x e to the 1 over x plus c times e to the 1 over x. And that's going to be our solution. That's going to be our solution to the differential equation that we solved.